Hi everyone, I'm Ms. Milkowski, the mathematician, and today we're going to talk about logs. All right, so I want you to solve for x in this equation. Now I know what you're thinking. You're looking at it and you're like, that is just way too complicated. And I completely understand how something like this looks overwhelming. But it's actually not as overwhelming as you think. So when you're looking at something like this, I've seen kids just say, well, first of all, logs, so nope, you know. And second of all, there's just too many. I mean, I see x in two different places and it's an exponent in one place and I have no idea what to do. So what I'm going to tell you is when you're not sure what to do, whenever you're dealing with a log, why don't you try to write it in exponential form? Sometimes rewriting it in a different form will allow you to see something that you might not have seen otherwise. So that's what we're going to do first. We're going to write it in exponential form. So as we know we do our little loop-de-loop, and you've heard me say b to the y equals x, okay? And if we're going to write this in exponential form, we end up saying that it's 2 to the 3 minus x equals, and then 6 minus 2 to the x. Perfect. All right, so now we still have an issue where we've got, x is in the exponent. And so the next thing I'm going to say is try to break things down. So let's rewrite this as 2 to the third times 2 to the negative x, okay? And then that equals 6 minus 2 to the x. Now at this point we have a negative exponent. So we know that when we have a negative exponent, we can make it positive by having it change levels, okay? And if you want to see an example where we do that, you can click right over here. And you'll see an example of me, not this problem, but a different problem where we talk about moving levels and stuff. So let's move this down, okay? And I'm also going to say that instead of writing 2 to the third, I'm just going to write it as 8. Okay, so it becomes 8 over 2 to the x, and then that equals 6 minus 2 to the x. All right, so things are looking better. I see a 2 to the x in two places, which, to me says I might be on the right track. But I have a fraction. And I know not everybody is as much of a fan of fractions as I am. So that's okay. You don't have to be. But you can just make math work for you, like you've heard me say in other videos, and just eliminate the fraction. So you say, I don't like that. Great. Use math to get rid of it. Use math to fix it. So if I were to say, well, I don't like it, well, how can I get rid of it? Well, I just multiply by 2 to the x, because then, see ya. Okay, calculator denominator, you've heard me say that a lot. Okay, well, I can't just multiply one side of an equation by something and not do it to the other, right? Otherwise, I just messed up the whole thing. So I need to multiply this by 2 to the x as well. Okay, so I'm going to draw that in. Now, always draw your distribution lines. I can't tell you how many times students make mistakes just on regular homework problems or on assessments because they forgot to draw their distribution lines. And sometimes, even drawing them, we've made mistakes. I've made mistakes. All right, so let's simplify this side. So this becomes 8 because this went away. And then it's going to be 6 times 2 to the x minus, and then 2 to the x times 2 to the x. Okay, now I'm just going to simplify this. 2 to the x times 2 to the x. So when we have two powers with the same base, we just add the exponents. So we're going to end up with 8 equals 6 times 2 to the x minus 2 to the x plus x is 2x. Okay, awesome. Now, I'm not exactly sure what to do, but I think maybe, since I'm solving this algebraically, because obviously in the first step we could have solved it graphically if we wanted to, but we're going to do it algebraically. Let me get everything on one side, because sometimes when I have everything on one side, things become more clear, okay? So what I'm going to do is I'm going to add a 2 to the 2x to both sides, okay? And then I end up with, over here, let me maybe draw a line so we can see, okay? So I end up with a 2 to the 2x, okay, plus 8 equals 6 times 2 to the x, okay? And then let's subtract 6 times 2 to the x from both sides, okay? And I end up with a 2 to the 2x minus 6 times 2 to the x, and then plus 8 equals 0. All right, perfect. Now, something is making me think for a second because I see a 2 to the x here, and I see a 2, not to the x, but to the 2x. And I'm wondering if I were to be able to somehow make this a 2 to the x, what I could do. So this is again where we have to use math to our advantage and have math work for us instead of the other way around. Think about another way to write this, okay? Another way to write this is 2 to the x squared. Because remember, if we have 2 to the x and we raise it to the second or the third or the fifth or whatever, we multiply the exponents. Like here, when we're multiplying, we add, okay? When we're raising it, we multiply. So this would be 2 to the 2x. It's just another way to write it. And then look at this. Okay? Now, you know what? I'm going to leave this open because I'm going to be using it. Let's take the green. Look at this. I've got a 2 to the x, and I've got a 2 to the x. Okay, there was a multiplication sign in there that accidentally got messed up. And then plus 8. This is really interesting. 2 to the x squared minus 6 times 2 to the x plus 8. Imagine if instead of that being 2 to the x, it were just x. X squared minus 6x plus 8. Would you know what to do with that? You absolutely would. Okay, that's a quadratic. So let's do a little bit of substitution here. So I'm going to say that u equals 2 to the x. Okay, so basically anywhere that I see a 2 to the x, I'm going to put a u. Okay, so in this case, I've got u, and then I'm going to leave this like this. U, because I see a 2 to the x, so I'm replacing it with u. Okay, u squared minus 6 times what? U. And then plus 8 equals 0. Okay, so then I can just write that as, you know, u squared minus 6u plus 8 equals 0, and now I can factor it. Now I can factor it. U squared minus 6u, okay? Now remember, u is 2 to the x, which we're going to deal with in a second, but u squared minus 6u plus 8 equals 0. So that's just going to factor, okay, into, well, u, because the coefficient here is 1. And then this is addition, this is subtraction, which means these are both subtraction because I need to multiply to a positive number, minus, minus, and add to a negative number, so minus, minus. So what multiplies to 8 and adds to negative 6? That's going to be 4 and 2. Okay? So it just becomes u minus 4 times u minus 2 equals 0. All right? So now we use that zero product property, which we love. So that becomes u minus 4 equals 0. So u equals 4. If I add, you know, I'm going to show that step there, adding 4 to both sides, right? So u equals 4. Boom. And then over here, u minus 2 equals 0, so I add 2 to both sides. Okay, so in this case, u, oops, I'm supposed to do it in black here. Okay, u equals 2, boom. Okay, now a lot of students will stop here and say they're done, but they're not. You're not done, because you solved for u. Remember, the whole reason we did a substitution was this got a little too messy, okay? So what we're going to do now is we're going to say, okay, if u is really 2 to the x, okay, I'm going to come up here, okay? So I'll draw another kind of column here, okay? And I'm going to say, well, u equals 2 to the x. So remind yourself of that. So u equals 2 to the x. So that means wherever I see a u, I'm going to put a 2 to the x. So if I say u equals 4, okay, that means I'm saying 2 to the x, okay, equals 4. So then you ask yourself, 2 to the what will give me 4? Well, that's easy. That's 2 squared, right? Equals 4. So therefore, x must equal 2. Boom. And then I take my other one, which was u equals 2, and I say u equals 2. So remember, u is really 2 to the x, so I write that as 2 to the x. Okay, I should have written that in green. Maybe I will write that in green. I don't know, I think the colors usually help. You know, if you weren't a fan of the colors, let me know in the comments, because I'll stop doing it. I feel like a lot of the times colors are helpful, but you know, maybe sometimes they're not, so you just let me know. Oops, 2 to the x. See, this green marker is kind of dying there. So 2 to the x equals 2. So 2 to what power will give you 2? And that's just 1. 2 to the first equals 2. So therefore, x must equal 1. Okay? Perfect. All right, and you always want to check, okay? You always want to check by plugging it back in. So I'm kind of running out of room here, but maybe I will erase. I can erase here so that we can do some checking. Okay. These markers just really like this whiteboard. Okay. Awesome. Okay, so let's try when x equals, what did we say? I can put this green one down now. Okay. When x equals 2, we'll start with that first. So then if we plug it in up here, so log base 2 of 6 minus 2 squared, does that equal 3 minus 2? Okay, so log base 2 of 6 minus 4, and does that equal 3 minus 2? Log base 2 of 2, does that equal 1? And that's true. Log base 2 of 2 does equal 1. Okay, so x equals 2 works. Now let's check x equals 1. So now when x equals 1, that's going to be log base 2 of 6 minus 2 to the first. And does that equal 3 minus 1? Okay, so that's going to be log base 2 of 6 minus 2 to the first is 2, so log base 2 of 4. Does that equal 2? And, okay, so this is where, I can tell you right now this is a true statement. Log base 2 of 4 does equal 2. If you want to see just kind of like a middle step, okay, you could write this as log base 2 of 2 squared, right? Because another way to write 2 is, another way to write 4 is 2 squared. And then remember, okay, that power rule that will allow this to come in front. So then you end up with 2 log base 2 of 2. And you want to know, does that equal 2? And well, log base 2 of 2 is 1. And oh my gosh, I totally ran out of room. So 2 times log base 2 of 2. So remember, log base 2 of 2 is 1. So it's going to be 2 times 1. And does that equal 2? And that's a true statement, okay? So both of them work. Now, there's only one little piece that I kind of want to draw your attention to, and that's over here. So remember, I said 2 to the what equals 4? Well, 2 squared equals 4, so x equals 2. Another way to kind of look at that, just in case, because remember, it's so super duper important for you to understand that there are multiple ways to do problems, right? I don't want you to think, you know, oh, because Ms. Milkowski did it this way, you know, I have to always do it this way. No, 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 no. You have to do the way that works for you. As long as it's mathematically sound, I'm happy and I will approve of it. All right, so another way to write that is if, I'm gonna just do it in black here. So we have 2 to the x, okay? What if we write 4 as 2 to the something, okay? We get the bases the same. So it becomes 2 squared, right? Another way to write 4. And then you remember that property of if they have the same base, the exponents must be equal. So x equals 2, okay? And then likewise, if we had 2 to the x equals 2, we can rewrite that as 2 to the first, okay, on this side. And then again, because the bases are the same, the exponents must be equal. So then x equals 1, okay? I know the other way was easy because you're like 2 to the what equals 2? Well, 1. And then 2 to the what equals 4? Well, 2. And that's great, you know, if that was easy for you. But if you like this sort of, more, I don't want to say like methodical way, I suppose, you can just rewrite it with the same base. And this comes in handy, like especially if it were something like x plus 3, you know what I mean? And then you'd have to set those exponents equal to each other. All right, so there you go. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.